Hey folks, today what we're going to be doing is I'm going to show you a sort of an outline of what we have done so far, or what we have done for this unit rather, called Forces at Work, which is essentially a look at some physics concepts. So this is what our test is going to look like. It's broken down into a few different areas, as you can see. So the test is going to be made of two main parts. There's a section on working with the formulas that we looked at. So we talked about there being a section on matching formulas, and then once you had matched all the formulas, then I would give you some math problems that we've been looking at as we covered this unit. The second part would be the written component of the unit assessment, and then we'll be looking at some through-line incorporation as well. So this is basically what I'm going to give to you is a framework for this unit. I'm not going to give you every single definition in this video or in this review. I'm not going to flesh everything out. So much like a framer will give the basic structure of a house, there are other people that have to come by and fill in the walls and plumb the house and wire the house and all that stuff. So your job is to fill in that stuff. I'm just providing you guys with a framework. The first part that we looked at in this unit was work, and so lesson one is called Forces Are Always With You, and we looked at things like how to convert grams into newtons. We talked about the difference between contact and non-contact forces, and then below that are the 9 different kinds of force that we studied. So there's elastic and buoyant, tension, compression, shearing, friction, electric, magnetic, and gravity. And so we looked at those different things over the course of a couple of days. You should be able to probably define those things or be able to describe them somehow. We went from there onto lesson 2. The lesson's called Can Something Massive Be Weightless? This is the first time that we were introduced to the concept of force equaling mass times acceleration. We're going to measure force in newtons. Mass is always measured in kilograms, so sometimes you guys will have to do a conversion in your stuff. And acceleration, we decided that it was acceptable to round it to 10 meters per second squared. I know it's 9.8 meters per second squared. We can deal with 10, I think. From there, we moved on to section B, which is called work, and lesson 3 focused on something called let's get down to work, and this is where we're first introduced to our formula of work equaling force times distance. Work gets measured in joules, force gets measured in newtons, and distance then is measured in meters. Again, it's your responsibility to talk about and to look at your notes, to look through your stuff and flesh out work and how we calculated work and all that stuff. I'm still, again, providing you with the framework. So that got us on to part C, which has to do with energy, and lesson 4 had to do with kinetic and potential energy. So I need you to be able to define both words and be able to describe the change from one to the other, so from kinetic to potential or from potential to kinetic. We had that pendulum description that we looked at, so think back to that. From there we moved on to the law of conservation of energy, and again I need you to be able to tell me what it is, to describe it. I may need you to be able to trace the energy conversions, maybe possibly from the source to the end. So one form of energy turns into another and has a different application. It can then turn into another and have a different application. So be able to discuss and describe those energy conversions. From there we moved on to part D, which was our machines study. And so we started in lesson 6 by looking at simple machines. So we were introduced to the 6 simple machines that are listed there. And from there we moved on to lesson 7, which was the advantage of the inclined plane. This is the first time that we're introduced to a couple of new formulas where we calculated the efficiency of a simple machine, and it's there in that formula: efficiency equals work output over work input times 100%. From there, we also looked at something called mechanical advantage, and we were able to calculate mechanical advantage as force without the machine over force with the machine. From there, we moved on to lesson 8, which was using levers, and we talked about the 3 different classes of levers and showed some examples, and I asked you to figure out some different types of levers. This is also where we're introduced to that formula F1 times D1 equals F2 times D2 to basically make sure that work equals work. From there, we moved on to reinventing the wheel, and we learned the concept that the wheel and axle function basically like a lever. When the two things are combined, the wheel and axle combined together, it functions like a lever. From there, we moved on to lesson 10, which was gaining an advantage using a pulley system, and we discussed and you guys explored things like movable pulleys, fixed pulleys, and you were introduced and asked to solve some problems that involved pulleys, not mathematically, but just logically. From there, we moved on to the last part, which is what we talked about the other day on stewardship. We looked at the lesson 12, which is ethics in an age of technology. And so we had the question about whether or not incorporating technology into our lives is worth the trade-off of increased pollution in our environment, and then consider why or why not, which is basically coming up with a rationale for your answer. And that's essentially the unit that we looked at. It took us a couple months to go through this stuff, but that's the framework that I'm going to provide for you guys. And so hopefully that will guide you as you create your own review sheet and prepare yourself for this test, which at this point is looking like it's going to be kind of a big one. So best of success to you as you prepare your review sheet, and I'll talk to you soon.